In this module, we'll take a closer look at the TypeScript compiler. Thus far, we always just used it by running tsc and then pointing at a file which we want to compile. Now, whilst that of course works, it's not really feasible for bigger projects where you have multiple files or where you simply don't want to run this command after every change you want to see in practice. In addition to that convenience, which we currently don't have, there also are a couple of interesting things you can configure regarding the compilation process, which actually change what is compiled and how it is compiled. And these are therefore the things we'll take a closer look at in this module. Now, to get started, I want to make sure that I don't have to rerun this command here, this tsc command where I point at a file after every change I make. Because right now, whenever I change something here in my TypeScript file and I want to reflect that in my output file and on this web page here, we have to save the file, run the compilation again, and then reload this file, or if we have our npm start process running, which we should have, then at least our browser will automatically reload if we don't directly open the file, but instead are on localhost 3000. But nonetheless, even though with that reloading automatically, we still have to manually rerun the compilation command. So to get rid of that, we can enter watch mode. And that means we can tell TypeScript to watch a file, and whenever that file changes, TypeScript will recompile. So for that, we can still run the same command, but now we add -- watch at the end, or just ~w. If we do that, then we are in watch mode on that file. And now whenever we change anything in there and we save that so that the file on the disk technically changes as well, you see this automatically recompiles. And of course, this also means that if we would do anything which is not allowed, like for example, reassigning to a constant and then a wrong type as well, whenever we try to do that, of course, it also recompiles, but then just as if we manually run the command, we see the compilation error down there. So watch mode is already a big improvement. The downside is that we still have to specifically target this file here. And at the moment, of course, this is the only file we're working with, but typically in bigger projects, that's not necessarily the case. So as I mentioned in the last lecture, watch mode is a great start, but what if we have more than one TypeScript file? What if we also have an analytics.ts file where we hypothetically send analytics data to our server? Now here, to just have anything in there, I'll just put in a console log statement, but of course you could be sending HTTP requests to your analytics service here, as I said. So let's say we also did import this file here in our index.html file. If we point at analytics.js here, which does not exist yet, but which will exist after compilation, then we could be loading these two files, and of course we want to compile both files whenever one of them changes. Now for that, it would be nice if we could enter some general watch mode where we just run tsc like this, so without pointing at a file, and it just watches our entire project folder and recompiles any TypeScript file that might change. Well, turns out that this is possible. For that, we just need to tell TypeScript that this here is one project that should be managed with TypeScript. And we do that by, first of all, and we only need to do this once, running tsc --init. So I'm not pointing at a specific file here. I just run tsc and then --init here. And again, this is only required once. It will initialize this project in which you run this command as a TypeScript project. That means it will now basically tell TypeScript that everything in the folder where you run this command, and therefore it's important that you navigate it into the right folder before you ran this command. With the built-in terminal here in VS Code, I'm automatically in this project folder where my files are, so that this project is now managed by TypeScript. So let's hit enter, and what this does is it creates this tsconfig.json file. This basically is the indicator for TypeScript that the project in which this file lies and all subfolders of this folder should be managed by TypeScript. Now, if we have a look into this file, we see there are a bunch of options, most of them commented out. They're just there so that you see that you could set them, and you got a short explanation here as well. But we don't have to worry about those right now. We'll dive into them in a second. For the moment, let's just close this file here, and let's see what this gives us. Because what it does give us is that we can now run just TSC like this without pointing at a specific file. And what this will do is it will tell TypeScript to go ahead and compile all TypeScript files, so all .ts files, it can find in this project. So if I hit enter here, you see this takes a while, and now what we got is this analytics.js file and this app.js file. Now the analytics.js file was just created by TypeScript because it found that we have the analytics.ts file, and as I said, it will now compile all TypeScript files in the project. And of course, this can also be combined with watch mode. You can run tsc-w or --watch as I showed before, and this will now enter watch mode for all TypeScript files. So now, whenever I change one of them and I save it, it will recompile. And it will recompile that file that changed and therefore also reflect the change in the JavaScript file. And hence now here, if I go back to my page, we see sending data here as well, because now the analytics.ts file was also compiled. So this is now how we can manage multiple files with TypeScript. Now, one word about having multiple files. When you work with multiple files, as we're doing it here, you can also import them into each other with modules, which you might know from vanilla JavaScript. There we have modules as well. It is something I'll cover in a dedicated section of this course though. So for now, we just have two files which are not imported into each other, but which are instead imported into index.html. Now with that out of the way though, we know that we can manage this as a project and that we can compile multiple files here. Now let's have a look at the tsconfig.json file, because this is a crucial file for managing this project. It essentially tells TypeScript how it should compile these files. Now, before we dive into the compiler options, where we, as the name suggests, can configure how the compiler behaves, let's scroll down to the place before the closing curly brace, but after this nested closing curly brace. And let's see some of the options we can add here which don't affect the compiler or the compilation step behavior, but instead how the compiler works with this project. Because there, for example, you can set a exclude option. Now, if you add exclude here, that will be an array. And what you can enter here are paths to files which should not be included in compilation when you run TSC on the entire project. So for example, here we could say we want to exclude analytics.ts from compilation. Now, of course, this doesn't make much sense here, but just to show how this works. If we do that, and we now rerun TSC, and I first of all delete analytics.js so that we can see if it is recreated. If we now run TSC or TSC in watch mode, you see no analytics.js file is created. And the reason for that is that we're excluding that file. Now, of course, for this file, this doesn't make a lot of sense because I typically want to include it. But if you had a file that for some reason shouldn't be compiled, you can exclude it like this. You can also work with wildcards. And for example, if you had a file that's named analytics.dev.ts and you don't really want to compile that, you could say all files that end with dev.ts should not be compiled. And you can do that by also adding an asterisk here, which is a wildcard basically. And now TypeScript will ignore any files that have .dev.ts included. You could also add asterisk / here, and that would mean any file with that pattern in any folder will be ignored. So these are things you can set up here. The only thing I want to set up here, and that is a setting you will often find, is that I want to exclude node modules. And the idea here is that I don't want to compile any TypeScript files I might have inside of node modules. Now, node modules is that folder that holds all the dependencies we install here in package.json. and the dependencies of these dependencies. And therefore, these are third-party libraries we're importing, which we don't want to touch. And if any of these libraries should ship some TypeScript code, then we certainly don't want to compile it. It will just slow down our compilation process, and in the worst case, it might even break our project. So therefore, it's quite common to exclude node modules here, though I will say, if you don't specify the exclude option at all, node modules is automatically excluded as a default setting. So you don't really need to add this option here. This would be the default. I just want to show that exclude exists and how you could use it. If the only thing you want to exclude is node modules, you don't have to add the exclude key at all. If you do add it though, you should set node modules, because otherwise it will not exclude that. Now besides exclude, we also have include, and include allows you to do the opposite. It allows you to specifically tell TypeScript which files you want to include in the compilation process, and anything that's not listed here will not be compiled. So if I point at app.ts here, you'll see if I rerun tsc, we also will get no analytics.ts file, or no analytics.js file, I should say. Why? Because analytics.js is not included in include, and as I said, if we do set the include key, then we really have to include everything we want to compile. So of course here, we could then also add analytics.ts here, and with that addition, we would start and compile it. As you see now, we have the analytics.js file. Or as an alternative, we specify a whole folder here, which typically holds the files we want to compile. Exclude, by the way, if set alongst include, will filter down include. So if we exclude some subfolder of a folder that is part of include, then that excluded subfolder will be excluded. So basically, we compile include minus exclude. Now, of course, here I don't want to set include. I want to compile all TypeScript files, and therefore I don't have to worry about that. Excluding node modules is all I need, and as I explained, theoretically I don't even need to add that because that would be excluded by default. Now you also have a files option. This allows you to point at individual files, so it's a bit like include, with the difference that here you can't specify whole folders which you want to include. Instead, you really just specify the individual files you want to compile. That might be an option for smaller projects where you know you will only work with 3 files, and for some reason you got a couple of other TypeScript files which you don't want to touch though. Then you can set a list of files like this. In reality, you might not need that setting that often though. And therefore, that's it with the basic compilation or project management options here. Now, of course, there is way more we can specify though. Way more we can specify about the compiler itself and how it behaves during the compilation step. So now that we have an understanding of how we can manage our files with the compiler, let's dive into the compiler options, because that's really interesting. This allows us to control how our TypeScript code is compiled. So not only which files, but also how the files which are getting compiled are treated by TypeScript. And there you see we have a bunch of options. Now you got short explanations next to these options. Some explanations arguably are a bit cryptic, others are quite clear. And I will say that a lot of these options, most of these options, will not matter in most projects. So you'll not set all of these options, not even close. You typically can ignore a lot of these options. Now I will pick up on the important options here throughout this course, because some options only make sense when we learn about a certain feature. And I want to dive into some options right now already though. And for that, let's go through that file from top to bottom and see what we got there. And let's start with the target option. As you see, this actually is set by default. It's not commented out. And what you do with this option is you tell TypeScript for which target JavaScript version you want to compile the code. Because what TypeScript does is it does not just compile new features like the type annotations that don't exist in JavaScript to JavaScript code. So it does not just take care that this here works, it also compiles the code to JavaScript that runs in a certain set of browsers. And you basically define which browsers support the compiled code by setting the target. The default target here in this project, as you see, the initial target which is getting set up is ES5, which means all TypeScript code is compiled down. And we can actually see that. If I run tsc here to compile all my files, we see in app.ts I'm using let and const. But in app.js, we see var. And that happens because we got a target of ES5. And in ES5 world, we don't have let and const. So the good thing here is that we can use TypeScript to generate code that works in older browsers as well. But it's totally up to us if we want to do that. Maybe we don't want to do that with TypeScript because maybe we got some other build tool that will then take care about the JavaScript transpilation, and therefore we don't want to have TypeScript do that. Or maybe we want to ship code that only works in modern browsers because we know our app only will run in modern browsers. And therefore, alternative options can be seen here if you delete the value, and then here in VS Code at least, if you hit Control Space to get the auto-completion, you see a bunch of suggestions and you see all available values here. Now over time, this of course will change because we got new JavaScript versions released. You saw we set this to ES5 before. If you don't specify target at all, then right now TypeScript compiles to ES3 even, so it supports an even older version. But you can also go with ES6, which is more modern, which for example supports constant let, or take an even more recent version. ES6 is the equivalent to ES 2015, just for the record. So if we set this to ES6, for example, and I rerun the tsc command after changing the tsconfig JSON file, you will see that now in app.js we got let and const, because now that is supported there. So that is up to you. Of course, the more modern of a JavaScript version you pick here, the more concise your generated code is, because TypeScript has to compile less and less code, or it has to work around non-existing features in less situations, and therefore the compiled code typically is then more concise and shorter. So that's the target. What about the other options? We also got module here. Now, module is an option I'll skip for now because it really only makes sense once we learn about modules in TypeScript and how we can connect multiple files. So let's ignore that for now. Lib is an interesting one though. Lib is an option that allows you to specify which default objects and features TypeScript knows. With that, I mean things like working with the DOM. Let's say in index.html, we have a button. And on this button, we say, click me. And when we click this button, we just want to print the message. Now in app.ts, we can select this button. We can get access to this button with document, query selector, for example, selecting the first button we find. Now, if we do that, then this works. We get no TypeScript error here. So if I go to my button and I add an event listener here, I get an error here actually because TypeScript doesn't know for sure whether we find a button here. For now, we can work around that with an exclamation mark after this line, and I'll come back to what exactly this does in the future. It basically tells TypeScript, don't worry, such a button will exist. We will get a value here. So now we can add a click event here and then define some anonymous function maybe where I console log clicked. Now, the interesting thing here is not so much that I had to add the exclamation mark. As I said, I will come back to that. But that if I run tsc, this just compiles. Now, shouldn't TypeScript complain that document is unknown to it? How does it know that we have such a document constant or variable available? How does it know that even if we have that available, that it holds an object which has a query selector method? How does it know that button is something which has an add event listener method? How does TypeScript know all of that? Now you might say, of course it knows, because in vanilla JavaScript this would be valid code. But keep in mind that when you write TypeScript code, you don't necessarily write it for the browser. You could be writing your Node.js application with TypeScript, and there indeed this would all not work. So the reason why this works is this lib option. And as you see, it's not even set here, but if it isn't set, then some defaults are assumed. If it's not set, the defaults depend on your JavaScript target here. And for ES6, it by default includes all the features that are globally available in ES6. for example, the map object, which is available in ES6. Therefore, it wouldn't complain if you use map. So it assumes all these ES6 features, which are made available globally in JavaScript, that they are available in TypeScript as well. And in addition, it assumes that all DOM APIs are available. You find the detailed descriptions about all these options, by the way, in the official docs, which are linked in the lecture at the end of this module. So long story short, if the lib option is not set, some defaults are assumed, and these are typically the defaults you need to have TypeScript run in the browser. So all the DOM APIs and so on. If we comment this in, and I now compile everything, I therefore get an error, because now by commenting it in, we don't have the default settings anymore. Instead, we now say, hey, please include some default libraries, so some default type definitions, you could say, which I will give you in this array. And as you see, I'm not passing any description, any paths, any values here. And therefore, what I'm saying to TypeScript now is, hey, regarding all the defaults you know, please take this into account, and you know nothing. So only if that's commented out it works, because then TypeScript will assume some defaults. If I set the defaults explicitly, well then TypeScript of course adheres to what I'm setting here. And hence here, for example, it doesn't know document, it doesn't even know the console here. So therefore, we want to set this to more reasonable values. And again, if you hit Control Space in here, you get auto completion. And for example, there we could add DOM. That's an identifier, and there are some predefined identifiers which TypeScript understands. Again, you find a complete list in the official docs. The docs for this option are attached to this lecture as well. So this is an identifier TypeScript understands, and it's an identifier which basically unlocks all the DOM APIs in TypeScript so that TypeScript understands what you're doing there. So now already you see it knows console, it knows document, and so on. So now, since we're working with next-gen JavaScript, we should also add the ES6 option so that TypeScript also understands all globally available ES6 options. And it's also a good idea to add DOM iterable and script host. With that here, we would unlock all the core JavaScript features you would want to work. And this, by the way, is the exact default setup you get when you set target to ES6 anyways. So if you comment this in and set it up like this, you have exactly the same behavior as if you don't specify lib at all. Now here I will comment it in though, and with that, this will compile. Again, setting this is a bit redundant though, just want to explain what it does. Now, also interesting is allow.js. With allow.js, and by the way, also with check.js, you can also include JavaScript files in the compilation. Now, with allow.js, a JavaScript file will be compiled by TypeScript. So even if it doesn't end with .ts, TypeScript will compile it. With check.js, it will not compile it, but it will still check the syntax in there and report potential errors. This could be nice if you don't really want to use TypeScript, but you want to take advantage of some of its features. And as far as TypeScript can help you with the any type only, which is effectively what you have in JavaScript, it will do so if you enable these options. Now, we don't need it for this project, and for this project, we would want to make sure we don't double compile these JavaScript files, which do stem from TypeScript files. So we would have to tweak the include and exclude settings a bit. But you could use that in projects where you don't want to use TypeScript at all, or where, for whatever reason, you have some vanilla JavaScript files next to your TypeScript files, and you want to check the vanilla JavaScript files as well. Now, let's fast forward a bit. JSX is an option that can help you with React.js, which does not really matter for us here. Declaration and declaration map is also not important here. DTS files are an advanced concept which matter to you if you're shipping your project as a library to other people, and you need basically a manifest file which describes all the types you have in your project. That's such a DTS file. Source map is an interesting one though. Source map helps us with debugging and development. So to show what this does, let me compile everything without that source map setting. If we now go to the browser and we want to understand what our code does, we can go to the Sources tab here in the Developer Tools, and there we find our JavaScript files. Now we can dive into these files, and The good thing is these files are fairly readable to us humans, of course, because they contain JavaScript code in the end. Now that's good, but what if we had more complex TypeScript code and we want to debug our TypeScript code and not the compiled JavaScript code? In other words, it would be nice if we would see the TypeScript files here and not the JavaScript files. With the source map option, you can get there. If you set this to true and you run the tsc command again, then you see we got these .js.map files being generated as well. Now, if we look at them, they're pretty strange files, but what they do is they basically act as a bridge, which is understood by modern browsers and the developer tools there, to connect the JavaScript files to the input files. So with these files generated, if I reload here, you see in the sources tab, we now not just have our JavaScript files, we also see our TypeScript files there. And we can even place breakpoints in the TypeScript files. And if I now click on that button, for example, it pauses in the TypeScript file, which is of course super, super convenient because that really takes our debugging process to the next level because we can work directly in our input files, basically in our TypeScript files instead of the JavaScript files. Now, nonetheless, here I'll comment this out because we have a fairly simple project here and I don't want to have these extra .map files lie around here. But this is super useful in projects because it simplifies debugging. Let's move on. We got the out file option here. Now, this option does not matter to us right now. It won't work right now. More interesting to us is outdir and rootdir. The bigger your project gets, the more you might want to organize your files. Typically, you don't just want to have your files lie around here in your root level project folder. Instead, what you often will see in projects is that you have a source folder and you have a dist folder next to next. So the dist folder has the job of holding all the output, so all the JavaScript files, let's say, and the source folder might hold all our TypeScript files. So we can move the TypeScript files into the source folder. And if I now delete the JavaScript folder, we have the problem that if we compile everything, these TypeScript files are compiled because TypeScript, the compiler, does look into subfolders, but the output sits next to our input files. And that's something we can control with the outdir, for example. If we set outdir, we can tell the TypeScript compiler where the created files should be stored. We could set this to dist. Now, if we do that, then if you run tsc, you will see that the JavaScript files indeed are not placed in the source folder, but in the dist folder. Now we just have to adjust our index.html file and there point at dist app.js and dist analytics.js, or alternatively move the index.html file into the dist folder, but then our dev server wouldn't work correctly anymore right now. So let's just adjust these imports. And with that, we got a working application still, as you see, but now with a cleaner project structure. Now, the good thing is, if we had a subfolder here, an analytics folder, let's say, and we had our TypeScript file in there, then if we recompile, and it does not matter if you do it with this command or in the watch mode, this folder structure you have in the source folder will also be replicated in the dist folder, which is of course very convenient because that makes sure that you can import the files basically as you would import them in the source folder as well, so that the structure you set up there is kept. Now you can also set the root directory and set this specifically at the folder where your files are stored in, like in this example source, to make sure that the TypeScript compiler does not look in other folders. That's also something you could do with the include option down there, right? But with root directory, the TypeScript compiler will not just look only at that source folder, it also makes sure that the project structure you set up there is kept in the dist folder. Now, it did so by default before, as you saw, but keep in mind that before, it would have included any TypeScript files here, also outside of source. So, for example, if we comment this out temporarily, if we had a user folder here on the top level with a user TS file, where we have a username of Max, let's say, then if we compile this, you will also see that user folder in the dist folder. And now the source folder is included as well, because now we have a TypeScript file on a higher level, and therefore the TypeScript compiler thinks that our whole project again as the input, and it replicates the folder structure it finds there in the dist folder. Now that's of course not what we would want, and that's where the rootdir option helps us. Now if we set this to source, even if we had other folders with TypeScript files in there on the root level, they would not be included in the output, and the source folder itself would not suddenly end up there. So often you set both rootdir and outdir to be really clear regarding where your input files live and where your output files should be generated in. If we move on, we can ignore composite. We can have a look at remove comments. Should be pretty clear. If you set this, then any comments you might have in your TypeScript files will be removed in the compiled JavaScript files. So if I comment this in and I compile my code, you see in app.ts I have a comment, in app.js it's not there. So you can do that to make your files smaller, and therefore this might be a nice option. You can also set no emit if you don't want to generate any JavaScript files. Now this might sound strange because that's the idea of TypeScript, but if you just want to check whether your files are correct, but you don't want to write all these output files to save some time, for example, in a bigger project, then you could set this to true to just have the TypeScript compiler check your files and report any potential errors without actually creating an output file. Import helpers is not really important to us here. We can ignore that. Down-level iteration is an advanced option. It is interesting when you compile your code to older versions of JavaScript and you work with for loops. Then in some rare scenarios, you could run into issues where the compilation doesn't work correctly. This option, if you turn it on, gives you a more exact compilation, which will work in these niche cases. So therefore, you might think you should always turn it on, but it will also output more verbose code. So you should only turn this on if you have loops and you see that your generated code suddenly behaves differently than it should regarding those loops. We can ignore isolated modules, but there is one other option, which is actually not even mentioned here, which I still want to mention myself though, and that's the no emit on error option. You can set this to true or false, and the default is false. And what does this do? If we set it to false, let me show you where this might be a problem. It is a problem if we introduce an error, or it can be a problem. Let's say here, I do have my button and I remove this exclamation mark. Now, even though we don't fully understand what's going on, the problem here simply is that TypeScript does not know that we certainly have a button here. After all, when querying for a button, we might not get one. If there is no element in the DOM that's satisfying this selector, then this will return null. And that's basically what TypeScript complains about. Here we access something on a potential null object, and that's not good. Now, that's an error we have here. If we compile our code, we also get this error here in the console. Nonetheless, the file is created. So even if I delete the app.js file, it will be recreated. So even if we have an error, TypeScript creates a JavaScript file. This might or might not be wanted. Maybe you have an error in your TypeScript file and you don't really know how to work around it, but you know it will not be a problem in the final app. Like here, even if we don't know about the exclamation mark, well, if we don't know about the exclamation mark, we might not know how to disable this error, basically. But still we know that this will work in our page here. So we might be fine with compiling this despite having an error. But of course, in reality, you should aim for error-free projects and rather learn how you can work around this issue than ignore it. Nonetheless, you could set this to false or not set it at all because false is the default if you are fine with generating JavaScript files if you have an error. If you set this to true, however, what will happen is that problematic files will not be generated. If I now rerun this, you see, nothing is generated actually. Even the analytics.ts file is not output there. If we have some content in there, besides console log, you see, it's not getting generated. And the reason for that is that we have an error in a file. And if any file fails to compile, no files will be emitted. So here, therefore, we have to make sure we fix this error before we then can get TypeScript to again compile files for us. And therefore, it is an option I typically like to set because I'm not interested in getting JavaScript files if I still have errors in my TypeScript files. So that was an important first set of options. Now let's dive into these strict options because these are pretty interesting. There is this strict true option, and actually what this does is it enables all strict type checking options. So effectively setting this is the same as if you would set all these options separately. So you can either set all these options one by one or just set this option. Of course, you want to set the individual options if you want to have some options set to false, because otherwise they're all set to true. If you want them all set to true, then using just this option is of course way shorter. Now what do these options do though? Let's start with no implicit any. No implicit any is a quite interesting option that helps us write better code. Let's go to our analytics file here, and there let's add a function send analytics that gets a data option, let's say. And there we could send this to a server, but here I'm just console logging it. Then I call send analytics with the data, so with the string. Now as you see, my IDE already complains here, and so does TypeScript, the compiler, because the two of course are connected if I try to compile this. Parameter data implicitly has an any type. So this seems to be related to this no implicit any option. Indeed, if I set this to false, so if I set all strict options to true, but I set this option to false, which I can do, then this error goes away, both in the IDE and when we compile the code. So what does this option do? It ensures, and I'll comment it out again to turn it on again because of strict true, it ensures that we have to be clear about our parameters, about the values we're working with in our code. Here, we don't give TypeScript any information about the type of data we'll get as a parameter here. And we should. If TypeScript is able to infer this, then of course it's fine, but here, how would TypeScript be able to infer it? From this line? Well, keep in mind that this function gets declared first before this file executes. So at the point of time when the function is created, there is no chance of knowing what will end up in there. So here, we can fix this error by simply declaring the type and being clear about which type we use there. Now please note that if you had a variable logged and you set this to true here, you don't get an error about this declaration, even though it also gets a default type of any. For variables, this is okay. For parameters, it's not okay. Why is it okay for variables? Because what TypeScript does for variables, what is possible for variables, what's not possible here because the function is created first. Here, TypeScript is able to track the values you assign. You see, okay, I got logged here like this. Now I set it to true. So therefore, thereafter, if I console log logged here, it's a Boolean. So TypeScript is here able to understand the flow of your code, and therefore you don't need to be precise regarding the type here. Of course, you want to be precise if you want to avoid that you can freely assign a new value, which you can do here because it is of type any. So you want to still assign a type to avoid this. But TypeScript is at least able to find out if the code you're calling works with the type it currently holds. That's not the case here because there the function is defined before you call it, and therefore TypeScript would have no chance of knowing if what you pass in there can be used inside of the function. Strict null checks is another important option. It's actually related to our button selection, which we have here. Remember, I had to add this exclamation mark here to make it work, otherwise I'd get an error. Now we can also get rid of that error without adding the exclamation mark by setting strict null checks to false. So let's do that here and let's save this. And as you see, this error is now gone here and I can compile all files. Now what do strict null checks do? They tell TypeScript to be pretty, well, strict regarding how you access and work with values that might potentially hold a null value. And button here might be null. It's not always pointing at a button element. It's not always pointing at such an element because even though you have such a selector here, a button might simply not exist on the page on which this script runs. And therefore, TypeScript can't tell because it's not diving into your HTML file and looking at that. It can't tell whether this will be successful or not. And if this fails to return a pointer at a DOM node, then it will return null, or undefined to be precise, but that's treated equally here. So therefore, then button might hold a null value, and therefore this code could fail. Indeed, if I comment out this button here, if I now compile everything, it works because I disabled the null checks. But I therefore now have a runtime error because I can't call event listener, add event listener on null. And I got null here because I got no button. Now this is a mistake we could avoid by setting strict null checks to true. And that's automatically set if we have strict set to true, where TypeScript anticipates that this might happen and therefore forces us to work around that. Now, one cheap workaround is this exclamation mark operator here. This tells TypeScript that you, the developer, know that this button exists or that this operation will yield a non-null value. Now, maybe you do. You certainly do if you know that you are working on the HTML code and that there is a button here, that this selector here will work. So it would be fine to use the exclamation mark in this scenario. If you have another scenario where you don't know for sure if it works and you just hope that it works, then it might be better to simply wrap the code that might fail in an if check, which will be there at runtime as well, of course. You could simply check if button is truthy, which it won't be if it's null or undefined, and move that code into this if check here. Now, even without the exclamation mark, in strict null checks mode, we get no error because TypeScript understands that this code is inside of this if statement and that this if statement makes sure that button is not null and that this will not fail. So this might actually be the cleaner workaround. However, of course, to save code, if you know with certainty that something does exist, using the exclamation mark is shorter and an absolutely fine option. Here I set both so that we see both. Of course, you just need one of the two things, either the if check or the exclamation mark. Strict function types here is a little bit of a more advanced setting, catching some niche bugs which you might not have in many applications. It is related to, well, function types you might be setting up. So not types inside of functions, but if you define how a function should look like regarding its parameters and return value, and you create such a function type, which you learned about in the basics module, then there you can introduce bugs if you work with classes and inheritance, which we haven't learned about yet, which we haven't used yet, and therefore for now let's ignore this. Strict bind, call, apply. That can be helpful if you do work with bind, call, or apply. For that, let's quickly see an example. Here we have our button and our function there. Now let's say this would be a function which we define here with the function keyword or as an error function. Doesn't matter. I'll use the function keyword here. Click handler. And in there, I console log clicked. And now here we point at click handler. And for some reason, we want to make sure that when this executes, we pass in certain arguments or we set the this keyword in there to a certain value. Now let's say here we do expect a message argument, which should be a string, and we want to output this here as well. Now, since click handler is passed to add event listener like that, so that the browser basically executes this for us, if we want to pre-configure the arguments which will be passed in, we can use bind. And bind as our first argument takes what we want to bind the this keyword to. And here we could say that does not matter to us because we're not using this in this function, so we bind it to null. Now you see here I get an error. I get an error that can be avoided if I set strict bind, call, and apply to false. Now you see the error is gone. Now what does this option do therefore? It basically checks on which function you're calling bind, call, or apply, and it checks if what you're setting up here makes sense. And here TypeScript sees we want an argument, we want a parameter in click handler. With bind, we're not configuring that though. And therefore here we get an error. If I set this back to true, or I just commented it out, because of course it is set to true by default by setting strict to true, we therefore get the error again. Now if we wouldn't expect an argument here, you see the error would be gone down there if we also remove the message, because TypeScript understands our code and sees you're not passing in any arguments to that method or to this function because it doesn't take any. So that's fine. But of course here we want one, so we get an error. The solution is to provide this second argument here, which is the first argument we want to pass in. Now, TypeScript is really smart here, and for example, if you pass in a number, it would still complain because it understands that I need a string here. If I pass in a correct string though, like you're welcome, then it does not complain anymore because now it understands this and it sees that this is matching my function definition here. So this is a very useful behavior that makes sure that you don't accidentally use bind, call, or apply in a way that does not work with your code. Now, strict property initialization becomes important once we work with classes. We can ignore it for now. No implicit this also does not matter right now. It has to do with the this keyword, and TypeScript basically tries to warn you if you use the this keyword in a place where it's not clear what it refers to. And always strict simply controls that the JavaScript files which are generated are using strict mode, so that this is added. With that, we covered all these strict options. Now if we move on, we got more options. No unused locals, no unused parameters, no implicit returns. This helps you with code quality basically. TypeScript will complain if you have certain unused variables and so on. So if we turn these three options on, for example, this option helps you with switch statements where you might forget the break keyword. But if we turn these three options on, what TypeScript will complain about is, for example, if you had a username variable here locally in this function and you don't use it. You see, this has yellow squiggly lines because it's not an error really, it's more like a warning or a hint. So if I compile here, you see now, however, I do get an error because TypeScript only knows errors. And there we see that username is declared, but its value is never read because we made sure that we don't want unused local variables. Unused global variables, so if I had something like app ID here, are allowed though because TypeScript can't know if you maybe need that globally defined value in another script file. So therefore this is allowed, but in a function where there is no other place where you could need it, TypeScript will complain now if you have unused code. And that's generally a good idea, allows you to strip out such unused code. Same goes for unused parameters. If you would take a age here, for one, of course, bind is broken now, but even if we pass this in, this works. But now again, TypeScript and therefore also the IDE tells us that this is unused, and indeed it is. So maybe we should remove it or start using it. So that's no unused parameters. And no implicit returns means that we'll get an error if we have a function that sometimes returns something and sometimes it does not. Let's say we have another function, add, where we get two numbers, number and n2 is a number. And of course we can return n1 plus n2. But let's say we're for some reason checking if n1 plus n2 is greater than 0, because we only want to return if we have a result greater than 0. And then we want to return the value. Otherwise, we want to return nothing. We don't want to return. Well, then we get a warning because of that extra setting with no implicit returns. TypeScript detects that not all branches in this function lead to a return statement. And because of our setting, that's not allowed. We at least have to deliberately not return anything here by adding the return keyword. Just omitting it is not allowed here. It is allowed if you have a function that does not return anything in no branch, but if you have at least one case where your function does return something, then you have to make sure you return something in all cases. And with that, we're nearing the end of this config walkthrough. We can ignore the module resolution here. All these options actually are pretty advanced. They don't matter to us here, don't matter to you in a lot of projects. Source map options allow you to tweak these source maps we had a look at earlier. So these translation files from JavaScript to TypeScript. Typically, default settings should be fine here. So if you don't know what you're changing and why you're doing it, you typically don't need to change anything here. And regarding these experimental options, I'll have a look at them specifically add experimental decorators later in the decorators module. This basically enables certain features to be used in TypeScript which are really experimental, where it's not sure if they will end up in JavaScript at some time in the future, and where you still might want to work with them. Then you explicitly have to tell TypeScript that you want to work with these features, and you can do that with that configuration, but again, I will come back to that. And therefore now we walked through this file, a lot of options you can set there, and as TypeScript grows, you typically also get more and more options added here. Therefore, the official docs are of course always a great place to dive deeper and to make sure that you don't miss an interesting option that might help you in your project. So now that we have a properly configured project, let's dive a bit deeper into how you can debug your project or how you can have a great development flow. I showed you my basic IDE setup at the beginning of this course. Really make sure you got the right extensions installed. There, for TypeScript, it comes down to ESLint, which can help you with linting your TypeScript code, so with improving the code quality, though you might need additional configuration for ESLint to have an effect. It can help you in more advanced projects though. But more interesting than that, you want to really use Prettier to automatically format your code and have a nicely formatted code. And you might want to give Debugger for Chrome a try, because that allows you to debug your TypeScript files even from inside VS Code through Chrome, but without using the Chrome DevTools. Of course, you can use those as well. As you learned, if you do enable source maps here, which you can of course always do, you get these translated files there as well, which is really nice. But you can also use VS Code. You can place breakpoints here, let's say in the click handler. And now to launch your files here through VS Code, you need to enable source maps as well, but we still will be able to use VS Code instead of the browser DevTools. So enable source maps, place your breakpoint, and then go to debug, start debugging. Now, the first time you run this, it should ask you for an environment, and there, with that Debugger for Chrome extension installed, you should be able to choose Chrome. It will now go to a launch JSON file where you configure how it should launch that. And there you should point it at localhost 3000 because that's where our development server is running. And of course, that process, so the npm start process, should be up and running. So point at localhost 3000 there. And as a web root, you can leave that placeholder here, which means this project folder is assumed to be the host of your files, which is the case. And now compile your code so that the source maps also are generated after setting the source maps config to true, so that we now have these in the JavaScript code. Then with your breakpoint added here and your launch JSON configured, let's run debugging here. Start debugging now for real, and it will open up a new tab now automatically. This tab will be closed whenever you quit the debugging process, or if you close the tab, the debugging process will quit. So now with that, you enter this debugging view here in VS Code, where you can track variables, watch certain expressions, and see the current call stack. And if you now click on Click Me, you should be taken back into the editor, and code execution pauses at your breakpoint in the TypeScript file. And now you can walk through the file here, inspect local values for the this keyword or for the message variable, for example, script-wide variables you might have, and global variables you got access to, global objects. You can watch certain expressions like message plus multiple exclamation marks, and well, then you can always track the value which is in there here in this window if you wanted to, so that would work. And you can see the current function call stack, for example, that we're currently in the click handler. And now you can step through your code with these controls to step to the next step, skipping over the next function call, stepping into the function call, or stepping out of the current function call. And the call stack, of course, here will adjust according to that. And with that, you can ignore this browser sync thing here. With that, you can always resume code execution by clicking the play button and only pause whenever you reach your breakpoint the next time. So this is how you can debug code. You can remove a breakpoint by clicking on it. This is how you can debug code from inside VS Code with the help of the built-in debugging tools, the Chrome debugger extension, the right configuration, and source maps, which are set up in your TypeScript config. And that's it for this module. We had a very detailed look at the TypeScript compiler, how you can configure it, and how you can make sure that it really compiles your code the way you want. We had a look at all these different options, especially the strict options really allow you to write correct code and not run into strange bugs, strange runtime bugs you might face, for example, with the strict null checks. And in addition to that, we had a look at debugging, how you can easily configure Chrome and VS Code such that you can debug from inside VS Code. Debugging from inside Chrome with source maps and the sources tab, of course, is always an option. The key here also are the source maps which you are configuring to be generated in the tsconfig file, which are these map files that live next to your JavaScript files. They basically act as bridges for the debugger between your JavaScript files and your TypeScript files. And with that, we know a bit more regarding how to manage our projects. Let's now see what else we can do with TypeScript and JavaScript.